Hello, it's video number 22, extracting spectra from ROI in ENVI. So, in the last video, we took our Landsat images of Middlebury, we did the radiometric corrections, and we computed reflectance, okay? In this video, I'm going to show you how to actually extract the reflectance spectra from those Landsat images. And the reason we want to do this, of course, is we want to use those reflectance spectra in a spectral mixing calculation. That's coming up in video number 23. So in this video, we're going to need to stack our reflectance layers quickly. Then I'll show you how to create a vector file again quickly. Then I'll show you how to convert that vector file to a region of interest. That'll be new. And then I'll show you how to display and export the statistics from the region of interest. Okay, so in our ENVI project, you can see that we've got all of our reflectance images loaded up. If you did not make a reflectance image for all 7 Landsat bands, please take a minute and do that so you can follow along with this video. Notice I didn't make a reflectance band for Landsat band number 8, the panchromatic band. So you just need to make reflectance images for bands 1 through 7. Also, importantly, I used band 6-2, the high gain thermal band, in order to do this. So take a minute, make sure you've got all your reflectance bands loaded, make sure they all look reasonable. And then the next step is going to be to quickly stack these into a new multi-band raster. To do that, we'll go raster management, layer stacking, import file. I'm going to select bands 1 through 7, not band 8. Okay, then I need to reorder them. Band 1 should be the top, then 2, 3, 4, 5, 6, and 7. So they're in order. That's a very important step. Choose a file name and a file path. I'm going to call this mid-July 99 stack. Use the .tiff extension. Okay. The projection information should be carried over. That should be all set. Alright, so we've now stacked into a multi-band image. I can go find that in Data Manager, and I'll visualize a red, green, blue combination. There's that. Then I'm also going to go ahead and visualize a thermal infrared combination. So band 4 will be red, band 2 will be green, and band 1 will be blue. There's my thermal infrared combination. Okay, so now we're ready to define some regions of interest. We're going to define 3 regions of interest. Each one is going to be an end member in our mixing calculation. So we're going to define one for spruce trees, we're going to define one for deciduous trees, and one for grass. Okay. So I'd like to define these end members up in the breadloaf area. This is an area that I know quite well. And we can see in this infrared image, this is the top of Breadloaf Mountain right here. The dark colors are spruce trees. They have very low reflectance in the infrared, so they're showing up really dark in this image. Just to verify that, if we look at the visible image, it's a little harder to tell, but I promise these are spruce trees up here. Likewise, this bright red is deciduous trees. So that's where I'm going to make my first 2 end member regions of interest. So to do that, I'll go File, New, Vector Layer. I'm going to call it Veg End Members. It's going to be a polygon file. Okay? So I've made that file now. And I'm going to go ahead and use the Vector Create button here. And I'm going to zoom pretty far in. And I'm going to draw a circle right around this patch of spruce trees. Double click to finish it. And I'm going to head up this way a little. And I'm going to draw my deciduous end member right in here. Make sure not to go too high up towards the ridgeline. I know that's a nice patch of deciduous trees along the Emily Proctor Trail. Alright, now finally, let's go ahead and define our grass end member I know a good patch of grass down here. It's actually right across the river from Middlebury. Some of you may know it, it's the soccer fields. Let me zoom out a little bit. So here's the town of Middlebury, here's Otter Creek, this little patch of bright green right here, right where the river takes a bend, is going to be soccer fields. Now I realize we can't actually see that very well because these pixels have been resampled pretty large. I'm actually going to turn off my stack for a second. I'm going to look at this under the band 5 image, and you can see that grass patch reflecting really brightly. So I'm going to go ahead and draw a polygon around this grassy area. Okay. So now if I zoom to this layer, you can see I've got 3 polygons: spruce trees, deciduous trees, and grass. So I'm going to right click, save that. I'm going to call it veg end member 1. It's going to have a dot shape extension. So I've saved that as a shape file. Now the next step is to add a field in the attribute table so that we can figure out which is spruce, which is deciduous, and which is grass. To do that, I'll right click, view edit attributes, and I'm going to go options, add a column. I'm going to name the column type, make sure it's set to be a string instead of a number, and I'll hit OK. And then I can go in here and add a little text to remind myself which polygon is which. So once I've done that, I'll go File, Save, hit OK, and I'll close the attribute table. Alright, so now I'm ready to convert this vector file into a ROI, or region of interest file. The key difference here is once I do the conversion, the region of interest file is going to be kept track of in terms of image coordinates, not lat-long coordinates, and it's going to always be tied to a specific image. Alright, so the way to do this is to go to our toolbox, down to Vector, in the very bottom, and then go Convert Vector to an ROI. I'm going to choose veg end member 1, the file I just made. And I have a few different choices. I'm going to choose unique records of an attribute to separate ROIs. That's going to make sure that each of those polygons I drew is going to be its own region of interest. And I'm going to choose type as the attribute. That's the field we just made, spruce, deciduous, or grass. And I'm going to hit OK. Now it's going to let me choose what file I want to actually tie this to. I'm going to tie it to my mid-July 99 stack. Hit OK. And note I did not tie it to either of the display stacks. Alright, so now what we've got is we've actually got regions of interest displayed over here. And notice that you will find them actually under the raster file that they're tied to. Okay? And you can see that green corresponds to deciduous, yellow to spruce, blue to grass, and so on. Okay, so now how do we actually visualize the average spectra in each of these polygons? So what's going to happen is, let's say you have 10 pixels inside each polygon. It's going to average the spectral value in any given band for all those pixels, and it's going to show us an average. So to do that, I'm going to right-click on spruce and go to Stats. And it's going to open this plot, which shows reflectance value as a function of band. And this is for spruce trees. So I'll go get the same plot now for deciduous trees. And I'll get the same plot for grass. Now notice these plots disappear. The windows are still open, they're just stuck back here. So I got to go back and find them, bring them up. Got them all next to each other now. You can see there's some pretty major differences. Grass is all over the place. Deciduous trees and spruce look very similar, except that deciduous has generally a little bit lower reflectance. deciduous trees has higher reflectance in most all the bands and has a little bit different slope in these visible bands. So this is a quick way to visually compare the spectra. If you want to save the spectra for later use, we'd go to File, Save ROI results to an ENVI stats file. Okay, I'm going to go ahead and put those I guess I'll make a new folder called Output. And I'm going to save that. I think that was my deciduous file. It'll have a .sta extension. Hit OK. Likewise, I can save that as a text file. Make sure that's still in my output. And I'll call this deciduous.txt. Hit OK. So now, just like we had done with ArcMap, if I actually go into that output folder, I can open up that text file, and you can see what I've got is the spectral reflectance information for the deciduous end member. Here's the mean spectral values, the min, max, and standard deviation. So I could plot those in Excel if I want. I've also got all the histogram information down here. How many points at a given value, etc., etc. So what I'd like you to do is make sure you're happy with your spectral reflectance curves for deciduous grass and spruce. Go ahead and save each of them as a text file and as a statistics file. So in review, we learned how to stack layers. We reviewed how to create a vector file. We learned how to convert a vector file into a region of interest file. And then we learned how to display and export the statistics for each region of interest. Please join us for our next video, Spectral Unmixing in ENVI, where we'll learn how to take these end member spectra and actually use them in a mixing calculation. Thanks.